Hello, everyone. Excited to be with you today to share some of the ideas and real-life case studies of how we utilizing innovation along the way throughout the entire life cycle of the project. For Windover construction, we I'm going to look for it's on there. Thank you so much. So actually, for us, innovation and technology is not necessarily about the latest tool or the latest drone or a laser scanner. It's more about the mindset of how we utilize today's technology with tomorrow's vision to offer a solution for a challenge that's happening on a job site. So the examples you're going to see is every project is unique, has certain challenges into it, and how we responded onto those challenges on job sites with the technology we have today. So a little bit about Windover Construction. We are Boston-based construction management firm. We build everything from hotels, academic. We have the go-to for modular construction in New England. We like challenging projects, so we build everything modular. We launched our IDEA platform, which stands for Innovations for Design, Engineering, and Automation, which extending our BIM services and prefab work around the US. And actually, we're doing work international too with Dubai developers. So we extended our leading edge technology to offer solutions and that's how we can help transform the industry. So the agenda today will be throughout the life cycle of a project and how we approach different challenges. We'll talk about pre-construction planning, early VDC constructability reviews, advanced MEB BIM coordination combined with real-time collaboration, laser scanning on real-time so we can mitigate risk. We'll talk about complex facade coordination, adaptive digital prefab, and digital twin, and how we're utilizing digital twin today on projects with case studies. So this is a project called the Cabot YMCA, a nonprofit client. And from day one, we started utilizing technology. It's got a very constraints in schedule and in budget. It won the Global Autodesk Excellence Awards for 2022 for transforming workflows using BIM, laser scanning, and the MEB coordination. So the challenge on that project is that we had to cut through the middle of the building, demo everything, and add an addition and upper 2 floors and extension into a historic building. So with all that comes with after demo, with all the surprises you would find in an existing buildings. Working on existing buildings is very challenging because at so many times you don't really know what's gonna be there after demo. So architects and designers can design things based on laser scan, but after we do demo, there are surprises that comes up and how we can help coordinate that in real time. For example, that vault for electric in the basement, we had to laser scan the vault after demo, do QA, QC. What you see in red is existing, what you see in blue is the new design, and how we do quick QA, QC overlays. This is a structural model. This is the existing. So one of the challenges we had on that project was that typically, as an existing building, for a 120-year-old building, the ceilings are playful. You see, it's not the same. So in Civil 3D, after we laser scanned that, we have spot elevation. All the ceilings are not the same. And this is a big fit-out project. The whole building got fit out. So we collaborated and partnered with Autodesk and with Howick from New Zealand and Struxsoft. What we did is that we took the BIM data we have into fabrication using telescopic studs. The power of telescopic studs is that you can you can fabricate everything in the factory, and it travel as small Lego pieces, and when it goes to its intended location, it can really expand and adapt. I call that adaptive industrialized construction. It can adapt with any ceiling heights and any dimensions to really quickly fit out that. That was putting into consideration all the future MEB systems that will get into there. It really helped us It was during COVID. It helped us mitigate the risk of delayed schedules because we already bought all the walls, and when the MEB systems were done, we were able to lower those telescopic studs and put them again. This is the workflow in the stud.io in the model. We took the model, we did the telescopic stud. You're going to see now we did all the fabrication at Autodesk Technology Center in Boston, which I consider a hub for innovation. We collaborate with folks like Great Howick from New Zealand, Struxsoft from Canada. So it's really helping that global collaboration, and this is one of the ways we can really advance the industry as a construction company, innovative only in the construction sector, but collaborating with manufacturers and with software developers, we can really push that forward. As you see here, we selected all the walls for each floor. It was 7 floors, 7-story, and you have the BIM data creating all the telescopic studs. This was the very first project to use this technology from Howick. At the Tech Center, we were able to fabricate all these pieces. I think it was only, each floor took 2-3 hours to fabricate. As you see here, it's called formed steel, taking the data. So it's taking the data to making. It's called formed steel, which many of us are very familiar with, but the beauty of this one, which is gonna come in the video now, is the flexibility for it to adapt with any height. So we're using it now on a life science project because we had only 2 months within the hospital to do the interior fit out, given the very constrained schedule. So we had really short time on site to assemble those studs versus traditional methods and cutting everything is gonna take twice the time. So what we did is that when we can really fit out spaces very quickly with interior fit out using this technology. It travels very efficiently to the site, as you will see here. And when it goes, it can go in a very tight elevators, very tight corridors. In a typical existing building, we used it in that's a historic building. And when it goes to its intended location, it can expand and adapt. This is we are helping also some folks who are supported by Autodesk Foundation to do some work in Africa. And what we found is that we can ship all these different small pieces, and when it goes there, it can expand to build walls for hospitals. So that's one of the technologies we used. Also, in that project, we used a new technology called Autodesk Takeoff. We can take the BIM data, and it carry over. It helped our estimating team early on in the process using the design model to quantify quickly. There's no need to go into a 2D platform and do the on-screen takeoffs or count how many doors, how many walls, how many windows, square footage for surfaces. It actually takes that BIM data and put it directly into even an Excel sheet, which they can extract with very quickly, very efficiently, so they can do their estimating workflow. Another example, we'll shift now, gives a little bit to another different project, which was a 15-acre site. And we've been one of the very early implementer companies to use drones in construction. LiDAR drones with ground control points to increase the accuracy of capturing data. For that site, for example, this is a multi-family. It's got a YMCA with a big sports facility. It's a big site. It became a standard for us, and we found it very helpful, is that and we build a lot of multifamily, whether it's gonna be a modular project or a traditional, or after putting all the MEBs for the underground, as you will see here, in real time, so say the plumbing trade partner put all the underground pipes, we go laser scan, whether with a drone, LiDAR with ground control points, or a laser scan, but we found in a big site like that, drone will be more faster. So then we do a QA/QC overlay. So you capture the data in the morning, for example, and in the afternoon, we already have an overlay QA/QC with all the underground pipes risers overlaid with the first floor plan. What that is important to do before pouring concrete is that, moving those pipes before pouring concrete is much easier, much cost-effective, and much faster than moving it after you pour concrete and go and break things. So what we did, it became a standard for all of our projects after we lay all the plumbing. In real time, we do these QA/QC overlays, and we detect up to, in that case, with 13 clashes, which each of them is a delay to the schedule. It can cause 2 days delays to move these things around after pouring concrete. And the key here is real-time QA/QC overlays. So you're working the VDC group or the laser scanning group, reality capture, working side by side with the superintendent on site. And you will see here that it takes the whole company mindset to move that. So if the superintendent doesn't communicate the timing of these scans with the VDC group, you're going to lose the opportunity to do that QA/QC overlay and detect the conflicts before they even become one. So the timing is important. The communication between the office, the field is very key in these examples. Another example that's in Somerville, Massachusetts. That's a public project for the government to provide multifamily affordable housing to combat, the shortage in affordable housing in Massachusetts, in the Commonwealth of Massachusetts. So that's a modular project. What you see here is a drone captured model. So we went there, we captured with the drone a 3D model of the site, the existing site. And what's that good for? Helped us with the logistics planning, the utilities, locating all the existing site utilities. We don't have to model it. It's already in the model there, exactly how the site looks today. And we're able to check for safety and how our boxes will come for modular. So using the site data coming from a drone data can really support the early permitting process, early site utilities coordination, and safety planning. That's one example of how we can use technology early on in the process. That's what you see on the right. That's a cut section through it. You see all the MEBs in the modular component and the site. Another example was a really nice restaurant in Boston, which we coordinated. It's an existing building that we built, I think, 10 years ago. And then they came, the client, and they wanted to change things on it and add different elements. So again, we laser scanned all the existing condition elements, and we were able to coordinate after demo. That's existing scan after demo, because when we approach a project, we scan it at the beginning. We supported the design team with the modeling, and you're going to see that in a really good example now after that. But also the key is to continue supporting the project after demo, after we uncover unforeseen conditions. So that's how we put all the pipes for the beer and all this coordinated with the laser scan. So it's really key to, so many times we coordinate things in Navisworks, and when we go to the site, sometimes even after months of coordination, you find surprises still on site. So that's why adding that layer of point cloud in Navisworks, adding that layer of point cloud, turn it on and off of what we have in the site versus what we have in the design, can really detect even more conflicts, and then you have certainty of outcome. When you go to the site, you are more confident with the data you have. That's a project that was set up in 8 hours in New Hampshire. It's a modular project. It was during COVID. We had very fast schedule, had to move very quickly. So these boxes came all the way from Canada, and drivers need to go back in the next day. So one of the reasons we were able to mitigate the risk and make sure that we're gonna have no surprises that day when we put these boxes is actually confirming the flatness of this slab we had. What we did is that we laser scanned. Our laser scanner get from 2 to 3 millimeter accuracy. And we laser scanned that, and to confirm that it is within a half of an inch. So we take that to Civil 3D, Autodesk Civil 3D, and they had a map of it with the spot elevations to see what the areas that needs attention from our trade partner to make sure it's flat. Why is that important? It's very important when you place all these boxes as a domino effect. You have to confirm this flatness within half of an inch. So that's one of the ways that we can, in real time, communicate any challenges on the site before these boxes come, and we confirm it what's happening. That's a very visual communication tool that we used. We used also, this is mixed reality. Actually, the software we use in this is actually Melbourne-based. Hologram, our partners. We are residents at the Autodesk Technology Center in Boston, and we have a fellow resident from Melbourne here, Hologram or Twin Build. they developed this really awesome mixed reality platform, which we're going to show we used it in different use cases. But what you see here is that we can overlay all the 3D models of the millwork or the MEB systems and different methods, and we can see how things will fit on site. The power of this one, using the HoloLens 2, is actually that you have QR codes. You put 5 of them on the site, and then when you scan them, so we go a day before we go with a laser scan, before we go with the HoloLens, with a client or with a subcontractor, or with an MEB manager, and we put all these codes, which I hope it will be showing in the next video. You put a QR codes in 5 different surfaces, and we laser scan that space with those codes. Then when you go back to Raafat, we locate these codes in place, and we ask the folks in the site to please never move these codes for a couple days. And then when we go back, you go to the HoloLens, and you assign and scan these codes, and that's what helps. It locks the model to 3 millimeter, very accurate, so we can view all these different elements. There is a delay in the recording, but when you put the the HoloLens, you can actually see all the different elements. It helps with real-time coordination, make sure everything will fit before fabrication. Whether it's pipes, whether in this case was millwork for an innovation space at Belmont Hill School in Massachusetts. Another project here, digital prefab. It's a YMCA with Olympic-sized swimming pool. We needed to create 1,000 truss, 935 trusses, roof trusses, in a very short time. So as you see here, we used the dynamo, we got approved, we used the engineering drawings to create these dynamo models and Raafat models, and we took that to fabrication with the Hout machine. And what you will see here is that after we created those 1,000 trusses, each truss was made out of 8 pieces. So you can imagine the piles of these different pieces of the trusses laying on a site. So to assemble these pieces, we used the hologram mixed reality. You know, it's like assembling IKEA furniture without having to look outside of the task in hand. So we're able to do that with 2 people, with 2 HoloLenses, in 3 days, assemble the 1,000 trusses, put them together, versus 7 days with 4 people. So that's an example of how we can use. First, we use the BIM data to create the fabrication with the HOIC. And then we use the mixed reality to expedite the assembly on site, to expedite processes, and increase safety too. And it was so much fun too. These guys who assembled these things, they loved it. So it's bringing efficiency to the workflows. So one other example of how we used different technologies to approach challenges and break the status quo in the project. So this is a historic building, 100-year-old building, historic in north of Boston. So what we did is that it was falling apart. It was done in plaster 100 years ago. And what we did is we did what we typically do in projects. We laser scanned it very accurately and had a point cloud, and then we took that point cloud into Fusion, Autodesk Fusion. We created a highly detailed model of all the facade elements. These intricate details, architectural intricacies that was done by hand 100 years ago, falling apart. We're able to create exact replicas of these pieces using additive manufacturing at Autodesk Tech Center in Boston. We're able to create these exact replicas with materials, with different materials. Some elements, it's really according to the request from the historic preservation folks. So they allowed us to do some with ProHT, which is a material that would not require any maintenance for another 100 years, and some with mahogany wood. So these beautiful rosettes, I think that project, the video was running faster. These beautiful rosettes and these beautiful details you saw, we were able to create exact replicas of them, exact replicas of them using the laser scan data, additive manufacturing, which is the 3D printing, to make something. So taking that BIM data and compared it to traditional methods, the end cost was almost 70% or even 60% cheaper than traditional method, which takes like a silicon and the traditional method is slower, much slower, as well as the accuracy we got from this was great because it carries over all the data we had in the laser scan into fabrication. So that's an example of how we can make, this and another example at Endicott College on how we use the QA/QC with the drone data to do the roof drains QA/QC. So we make sure that all the roof drains are on the same location. This again happens. All of this is real-time communication. If you do this a little late, it's not useful anymore. That's why it's very important that collaboration between on-site folks and technology folks. So the roof drain QA/QC, that's a modular project which we got involved with very early at Tufts University, one of the great schools in Boston. We're able to, before even the design team got involved with, we were able to do constructability review with them with these modular boxes. How's it gonna look? They show that to all the board to get approval, to show it to the parents on how the students will go. This is virtual reality. We put this on Oculus, show them how the spaces will look like. This is another way we can use technology early on in the process to help clients. This project at Dartmouth College, it's one of the most prestigious schools in the United States. And this terracotta here is done, was done coming from Spain. That glass was coming from Germany. And this building was actually, it's called the Anonymous Hall in respect for everyone who donates something anonymously at school. So what we did is that building originally was a library that built in the 1970s. And we had steel and concrete stuff. So after demo, the only left is the design is based on leaving all the existing structure to remain. So when the engineer designed that building a year before we demo it, or 2 years before we demo it, they actually thought the building is a square because they considered the drawings to be accurate, the original drawings. But what we did is that after demo, we laser scanned the building and we found that no, it's not square. It's not perfectly square because after 40 years or something, or 50 years, the building started to have some discrepancies into it. And that's very key when we communicate that very quickly to the engineering team and to the folks doing the terracotta walls and the glass walls in Germany. Because then we make sure we count for all these pieces. When they come, they fit perfectly on top of the existing structure to remain. So that's the importance of constant communication with scans, with BIM data between the field and the manufacturer. So we make sure all these off-site elements built off-site will fit perfectly on-site. This is an example of our MEP coordination for that project. Again, it's laser scanning the existing structure to remain and doing all this MEP coordination to make sure it's going to fit with the existing structure to remain. We didn't have that before demo. So we did coordination before demo, and then we revisited that after we had the demo so we can apply that layer of laser scan into the process as well. That's the importance of constant adding that layer of laser scanning into it's become a standard for us now, especially with existing buildings. The new build, it's really easier. So also we did virtual mockups, detailed virtual mockups instead of the physical mockups to make sure that all the pieces will fit perfectly when we set them together to save time on site. This project, it's called the Canvas. It was the winner of the 2019 Autodesk Excellence Awards. 300 projects from around the globe was submitted, and this project won. The reason for that was how we used drones and laser scans to do overlays to improve. So modular construction is already transforming the industry. This helps to add another layer of enhancing efficiencies and coordination between off-site components and existing. What happened here is that it's 256 units with all these modular boxes coming from Canada to the US. So what we did actually is that early on we had a challenge because we had the steel structure built on site and we had modular components built miles away from the site. And each of these has vertical shafts that has MEP systems in it. So how we make sure that when these boxes will arrive, will fit perfectly with the existing, with the on-site built components to it. So what we did after the erection of the steel in 3 phases, it was actually 2 buildings, we did a laser scan of the steel, as-built steel. So we make sure we are coordinating with as-built steel, not drawing steel. And there's a few inches or even few centimeters can make a big difference with that vertical shaft. So we detected more than 10 conflicts, and we tell them in the same day, the factory in Canada, hey, you planning on putting your boxes here in these red areas, it's actually gonna hit steel. So now the steel moved a little bit because it's built on site, just maybe 10 centimeters different or whatever. So they were able in real time to make all the changes and the tweaks to their models while they're fabricating the boxes in the same time, so to make up for these differences. So we made sure in the point cloud with the modeling, what you see in red is actually the existing on-site built steel, and the yellow was the design steel. You see little discrepancies make a big difference. So they will be able to move these vertical shafts to make sure all the MEBs will carry from the on-site steel for the podium, first 2 floors, all the way up. With that, we're able to make sure there are 0 clashes on site when we place those boxes. Another use of technology is that a technology like Civil 3D, which has been used for years to do topo and do spot elevations for in a plan view. What we did is that we used it on a facade view. So after you put all these boxes, you want to confirm, check the plumbiness of this facade after modular construction work. So what we did is that we laser scanned, and we were able to communicate that to facade team that, hey, that area is pumping a little bit up, so we make sure we preserve the design intent and end up with a very smooth, straight facade. That's QA/QC with using different tools. This is a project when it was completed. So that's another way. This is twin build, and I think that example, that video here, it's not playing. It had the codes in it, but you can Google it even when you get a chance. It's got Windover twin build. You're gonna find on YouTube videos about how we put the QR code in it. This is the same QA/QC overlays for underground plumbing, because I want to leave space for questions, so it's a two-way conversation. I'd love to hear what you guys think. Also here, it's becoming, you see here, this is wood. This is not even prefab. This is wood frames. So when we do typical coordination, we do coordination very well, and then when they go, they find hits in the site. It's becoming more standard for us now is to go scan in select areas these frames on site to make sure that we are also same idea, same concept, to move things in the model before fabrication so we don't have surprises on site. This is a best practice for us to document all the as-builts, and we deliver the client, whether it's a Matterport model or recap model of all the spaces. It helps them support, before closing up ceiling and walls, we scan everything, so 10 years from now, client would know what's behind ceilings, what's behind walls in each room. So that's the best practice for us. The last thing I want to touch upon is digital twin. So we've been, for more than a year now, working with Autodesk Tandem team on this great opportunity of adding all data. After we've completed every project, we end up with a fully coordinated 3D model, whether it's in Navisworks or any other software, but we have a fully coordinated 3D model. If we take that with a little bit of creativity and the investment in time, and it doesn't take longer than people think, what we actually did is that we take all this MEB coordination model and plug in all the O&M manual data. And what it does, actually, which our clients loved, we delivered it. This is Philips Exeter Academy. It has all the O&M manual data. When they select any of these elements, it gives them the installation date, the 24-hour contact, manufacturer information, everything in the O&M manual at their fingertips. They don't even need a QR code on site. And we actually connecting that to IoT sensors so we can track performance of the building energy performance. So this is really transforming the way we hand over projects. For years, we've been delivering piles of paper, and whether it's, without mentioning any different softwares, but they're all good, but just delivering that paper, clients never get to use it, and when they use it, it's not very efficient. But in the same time, there were a challenge that clients they don't have to be, they are not as good as we are in visualizing what's in 3D, in 2D, in 3D. They don't have to be BIM experts and know Revit. So what this web-based opportunity is helping is that delivering that with minimal training or no even training needed for those facilities manager guys, teams to really utilize it on site. So that's how we can transform handover and help the clients support their buildings many years to come. And that's the logic investment into the BIM data we develop over the life cycle of the project. For us as builders, we think that the life cycle ends when we hand the project, but it's actually the beginning for the owner, and that's how we can respond to that and support the future facility maintenance. Thank you so much. Are any questions?
Please, just we'll have time for one or two questions. Is there a microphone up in the middle? Can I see that properly? I thought there was. Or a roving microphone. So we've got time for one or two questions, and of course, Amma will be on the panel later on this afternoon. And while you're thinking of a couple of great questions, I mean, this is so interesting that this has been talked about for a long time with the that wasn't me, that was with the AMCA. We've been talking about this stuff for a long time now, 10 years, and it's actually being implemented. I mean, it was such a great set of examples of what's out there. I also noticed too that I love what you said at the start, it's mindset, today's tech with tomorrow's vision. And it really is, if you can imagine it, you can do it. We're now at the time when this is being implemented. Also the ideas of modularity. You know, buildings are becoming so modular now. We can learn so much from Lego. Things being built in pieces and then brought into place and put together. And just reinventing the past, how tech can respect heritage is such an interesting element there. So I just thought it was incredible. And even the idea that the way you were folding down that fabrication, there's a great documentary for all of you building nerds out there called The Origami Code. And it shows that the way nature does things is it folds things down so that it can be moved and then it expands them out. And there's really something interesting with that biomimicry that you're doing there.
Steve,
within the construction firm. So have we got some questions? I can't really see.
Steve, I'm over here now, just on the side. Shannon talking here. Just probably a question for Amar. I just wanted to ask you how you got the different teams within the business to collaborate and share that information, and what was, maybe just some of your thoughts on bringing that kind of mindset together of all the different parties.
You're bringing up a great point, Shannon. How we can inspire the whole and empower the company internally first to implement and embrace technology. It was starting from stop testing and start applying and doing. So what we did is that we just did it. We went there, we selected, as you see here, these all real life projects. It had schedule, had budgets, had clients calling us, is it done? Is it done? Is that those trusses, is this crazy idea you guys working on working? We say, yes, it's gonna work. So this pressure really is a great opportunity. We push our boundaries and work that. And that's how we went to the first time, maybe challenging even, but you get that aha moment, like the underground pipes. When you have the superintendent questioning, would that work? But when they see all these overlays and they see all these discrepancies, they say, oh, imagine if we had this discrepancy, it could have caused us that much money, and it can cause me as a super delays and schedule and problems on site with the subs. So what happened is that when they found this, it became now they call. Now they call us and say, oh, I am going to have all the pipes ready for you Friday morning at 9, if you can come. So showing by doing internally, you see the advantage of it. They try it once or twice, and then they become on board. So the most important thing is to stop testing and just start doing, even if for a smaller scale, and it grows.
Yeah, I mean, and from my point of view, and a point Steve mentioned earlier, the word courage. Did you see that as a role or something that you had to take? Taking on projects with that pressure from the clients. There's an element of courage in my mind. And I know you and I, Amar, we've spoken about passion too, so maybe just some thoughts on that.
So the pressure from clients actually helped us push boundaries because, for example, that historic preservation project, We had the historic committee on board with us looking at what we're doing. We invited them to visit us and see how we were doing the process. Said, we've never seen something like this. This is awesome. We should do this on many other projects. We actually got asked for we got other jobs because they've seen that kind of work, that it saves time and cost, and the most important thing, because these clients not necessarily only care about the cost, but they really care about the quality, the accuracy. So we're using today's technology, which is empowering us to capture all this millimeter accurate data and carry over. These beautiful pieces were done by hand 100 years ago. And unfortunately, we don't have now the skill sets to do this by hand. Would love to, but the time, things change it. So what we can do really to make up for that is using this technology to create exact replicas, or actually, I said that yesterday. People think that construction industry is only about hammer. So, but now it's more robotics, computers, but we want to get the new generations, the new school. We work with technical schools in New England to let students come visit us when we're doing this work at Autodesk or at on-site, so they can see and get excited about it. I want to be a builder. I want to be, so because it's fun too, because they use the virtual reality. And that brings us the skill sets we really need. But absolutely, client pressure really is always a great opportunity to finish things on time. And that's a real test for the technology, because we are also learning. The first project was harder than the second and the third. So it's been a learning curve for us as well.
Is there any questions before
yeah.
back to Steve?
There we go. We've got one over here.
Dominic, coming over. Thanks, Dom.
Thank you. Getting your daily exercise here, Shannon. Thanks, Amir. This was fascinating, and it's really great to see how far this is coming and has come, and it's probably also, there's more to come in the future. In how far have you guys now considered to push this even further, particularly when we look at the drones and the real-life QA/QC, sort of the capture? Is there a point where you could even connect it to other technology? I'm thinking about AI and others, where you can train it to also detect certain works being finished and then automate sort of approval and compliance processes with councils, and also regulate sort of like sign-offs and so forth? Is that coming?
So you bring up a great point. Great question. There are two components to this, how we carried over the drones. It's already in the technology, it can count. It's very smart. You can scan a facade and tell them, you select an item or an issue in it, and you tell me how many times this issue on that facade happened. So laser scanning, drone, LiDAR especially. So when we started this, we thought about drones more than an eye in the sky, more than taking pictures and videos. It's more about capturing real data that we can count on and embed into our BIM workflow. To your second part of the question, we are working now with a city that asked us to expedite BIM, the permitting process using BIM AI-enabled platform. So we're helping them develop that. We are considered like the architect who composing that platform. But part of that is a digital twin of the city. So we started, actually there was in one of these slides, this one. This is a downtown of Haverhill in Massachusetts. We've been asked by the mayor to scan the whole city site and then add that to the digital twin of the city, including some select buildings with thermal drone scan. So we know what buildings are emitting heat, and we did some recommendations. You can add a little bit insulation here, fix a window there to make the building more efficient. So, and we are doing it now with the permitting process. So drones can really be useful, especially in large areas, cities, and much more efficient than ground-based survey methods.